Hi everyone. In this video I'm going to provide a general introduction to path analysis with manifest variables using the AMOS structural equation modeling program. Now before we get started, let me note that underneath the video description you will find a link to a PowerPoint, and that PowerPoint contains a lot more information than I'm going to be providing in the video. The video is mainly going to be showing you how to set up and use AMOS in order to run a basic path analysis, but the PowerPoint goes into a lot more detail concerning interpretation of the results, and it also includes a number of citations that you may find helpful. Additionally, underneath the video description you will find a link to the SPSS data file if you want to download the data to follow along. Okay, so the data that we're working with is based off of an article by Zhao et al. From 2016. This was downloaded from the Plus One website. The article is entitled Relationship Between Anxiety and Burnout Among Chinese Physicians, a Moderated Mediation Model. So we're not going to be testing a moderated mediation model in this demonstration. Rather, we're going to be essentially respecifying the model to run just a basic path analysis. Now before we open up AMOS and begin laying out our path model, let me just kind of walk you through the basics of the model itself that we're going to be testing. So in this model we have a couple of personality variables. We have neuroticism and extroversion. So this is extroversion, this is neuroticism. And these are exogenous variables within the model, meaning that they don't have any variables upstream that are predicting them. So in this case we do have a double-headed arrow between them, and that's signifying that we are allowing those variables to correlate. The remaining variables within the model are endogenous variables, and the reason why they're endogenous is because we have other variables within the model that are predicting them. So you can see that we have single-headed arrow going to positive coping, to burnout right here, and negative coping right here, and then we have anxiety over here. So we have those single-headed arrows pointing to each of the remaining four variables within the model, and that's what makes them endogenous variables. You'll also notice that the endogenous variables have error terms associated with them. That's reflected by the circle with the arrow drawn to the box. So these are referred to disturbance terms. So you'll notice that I've got D1 right there, D2 right here, D3 right here, D4. These are reflecting the prediction error associated with the endogenous variables after we've accounted for their respective predictors within the model. So basically what we have for this particular model then, we have extroversion predicting positive coping, we have positive coping predicting anxiety, we have neuroticism predicting burnout, anxiety right here, and then negative coping here. We have negative coping predicting anxiety, and then we have burnout predicting anxiety right here. You'll notice that we have a double-headed arrow between D1 and D3, and that's reflecting the possibility that there might be a correlation in terms of the error terms. Basically, you might expect that positive and negative coping might be correlated with each other, even perhaps after accounting for the variables upstream. So at any rate, let's go ahead and open up AMOS and draw out our model. Okay, so this is the AMOS drawing program, and so we have this white space in the center of our page right here, and that's where we're going to draw out our model. You'll notice that on the left we've got various icons that are used for drawing, some are used for editing, and then some are used to specify analysis properties and to run our analysis. We also have this icon right here, which is used to actually import the data from SPSS into AMOS. So what I'm going to start off with is I'm going to go ahead and draw out the basic bones of the model, if you will. So I'm going to draw out the rectangles. Before I do that, I generally like to have a little bit more drawing space. So I'm going to increase this white space a little bit by going to the View tab, go to Interface Properties, and use the paper size. I'm going to go down to Legal right here, and that gives me a little bit more drawing room. And so now you'll see that we have these various buttons over here, and I'm going to click on the rectangle right here, and so now it's highlighted, and so now I can draw out a rectangle in this white space. And I can continue to draw this out. So let's say this is the rectangle for extroversion, and then we have our neuroticism variable right here. I could draw out my positive coping and so forth. The one downside of doing it freehand like this is that they may not all be proportionate. And if you want them to be proportionate to each other, that can be kind of a drag. So I can click on this little erase button right here. I'm going to get rid of these extra boxes, and instead of drawing all this out by freehand, I'm going to click off of this erase objects here and click on to this photocopier. It says duplicate objects. So I'm going to press that button, and so now when I highlight this box right here, I can click on it and drag, and so now I get a box that is exactly the same proportions as the original box. And so I can keep doing that all through this in order to draw out my model, so it makes it look a little bit nicer. And so there we go. Those are that's kind of generally where I want to locate my variables. So now I'm going to click off this button for duplicate objects, and before I actually start proceeding with any more drawing, what I think I'm going to do is go ahead and import my data. So this little tab right here, it says select data files. I'm going to click on it and then go to file name, and then you can go to your drive wherever your data is stored, and you can select it and then open up. And so now I've got my data file. You can see it's showing right here, as well as the number of cases in the data set, which is 1,129. I'll click on OK, and so because of that, now I can click on this button right here where it says list variables in data set, and I can actually drag the variables into the boxes. So I'll kind of go to the end of the data set, or the end of this list right here, and I'll select anxiety. I'll click on it and then drag it to where anxiety would be. I'll click on burnout and drag it over to the box for that, and then I'll go ahead and select extroversion and move it to its box, neuroticism, move it to its box, and then we have positive coping right here, and we have negative coping right here. So I can click off of this, and these are the variable names as they appear in SPSS. Now if I wanted to make the variable names a little bit more descriptive, I can certainly do that by right clicking and going to object properties, and you'll see we have the variable name as it appears in SPSS. So you cannot change that, but I can go down to variable label and I can basically give it a more descriptive name. So I can call this extroversion right here. And if I click on this box right here, I can go down to variable label and type in neuroticism here. So I can do that throughout for any of these variables if I want to. Additionally, if I want to change the font size, I can certainly do that. I can just kind of select a different font size, and you can see it gets smaller. It's a little harder to read, so I'm going to leave it back at 18 where it was before. So at any rate, at this point, what we're going to do is we're going to go ahead and draw in the correlation between our two exogenous variables, neuroticism and extroversion. So I'm going to click on the double-headed arrow button right there, and I can go to highlight the neuroticism variable and then draw up, and you can see the green is the the second variable, and you can see now I can draw in this double-headed arrow to reflect that. If really quickly, I'll use the erase objects and get rid of this and show you what happens if I go the other direction. If I start on this side of the box, this is what I what I end up with is going to is going to look like this, which is not particularly appealing. So I'm going to get rid of that and redraw right here. So we'll just redraw that right there. Next, we will draw in we'll go ahead and draw in our paths. So I'm going to click on the single-headed arrow icon, and so that button's now activated. And so now I'm going to draw in an arrow from extroversion to positive coping, from positive coping to anxiety right here. We have burnout to anxiety, and then negative coping to anxiety as well. And then we have neuroticism going to negative coping, and neuroticism also having a direct effect on the anxiety variable right here, and it's also going to be predicting the burnout variable. Then finally we'll add in paths from positive coping to burnout and from negative coping to burnout right here. So you might think we're all set then in order to run our model, but we're not quite there yet because none of our endogenous variables currently have an error term or disturbance term. So what we need to do is to go over here and we'll click on this button that says add a unique variable to an existing variable. And now we'll go to each of our endogenous variables and we'll click, and so now it draws in a circle and an arrow pointing from that circle to the box to represent our disturbance term. So if I click on this multiple times, you can see that we can reorient the disturbance term very easily. And I'll go ahead and do this for each of the endogenous variables within our model. Okay, so now we've got those drawn in, but we still have to give them names. If we don't name them, we're going to end up with a problem. So in terms of running the model. So what I'm going to do is click off of this button that we were working with and right click on a given disturbance term. We'll click on object properties right here, and under variable name I'm going to type in just D1 right there, and you can see it shows up. And then I'm going to go ahead and do the remainder. So I'm going to click on this one right here to give it a D2, then a D3, and then a D4. So importantly, these, the naming is arbitrary right here. I'm just giving a D1 through D4 just to signify that we're working with the disturbance terms. So I'll click out of that, and then I can also add in the correlated disturbance terms by clicking back on the double-headed arrow and then drawing this in as well. So there you go. And so if I want to reorient everything, I can certainly do it in several ways. One of the things that I can do is if I want to move the entire figure around, I'm going to click off of that really quickly and click on the open hand right here that says select all objects. So you can see it all turns blue. If I select the little moving truck, I can click on an object and then move the entire figure around. So that's pretty cool. So I can reorient everything within the white space. If I click on this button right here, it says deselect all objects. You can see that now it's changed, and the button for my moving truck is still active, so I can actually click on various individual objects and move things around if I want. If I want to stop that, I can just click off of that. Now I can't do it, so I can click back on, and I can move things around very easily. So that's some of the basics for drawing things out. Go ahead and click off of that. So now we're about ready to run our analysis. This is the basic model specification we started off with. So I'm going to go to this box right here that says analysis properties. So I'm going to click on it and go to the estimation tab, and you'll see by default we're working with maximum likelihood estimation. And one of the things to keep in mind is that if you have any missing data whatsoever for your variables, you're going to have to click on this button right here for estimate means and intercepts. If you don't, which is the circumstance with the current data that we're working with, there's no need to click on it. But if you do have missing data, then you'll need to click on it. Otherwise, when you run your analysis, you'll get an error message that says you need to click on estimate means and intercepts. So just keep that in mind when you are running your analyses. Next up, I'm going to go to the output tab, and I'm going to select standardized estimates and squared multiple correlation. So these are a couple of things that I typically select. Also, I'll go ahead and select indirect, direct, and total effects, because my model, as you can see right here, we are specifying some possible indirect effects. We're assuming, not only that neuroticism might predict burnout and burnout predicts anxiety, but that the effect of neuroticism on anxiety might be partially accounted for by the burnout variable. So in other words, that would reflect a mediational process. So if I want to capture indirect effects in my model, I can click on that button right there. All of the single-headed arrows in the model are direct effects. So again, if you want indirect effects, you'll need to click on that button. And if you want total effects, the total effect is nothing more than just taking the indirect effect between one variable and another and adding it to the any direct effects. So like for the neuroticism variable, the effect on anxiety, we have a direct effect which is reflected in this path right here, and then we have indirect effects such that we would be going from path A to path B right here. So if we take the product of A and B, that gives us part of our indirect effect of neuroticism on anxiety. Then we have, let's say we have this path, we call it C, and this path we call it D right here. If I take the product of C and D, that's also part of the indirect effect of neuroticism on anxiety. And then we still actually have another one. If this is path E right here, then we could take path C by path E by path B right here, and that would be yet another indirect effect. So if we sum all those together, they actually sum to a total indirect effect, and if we add that total indirect effect to this path right here, the direct effect right here, that's what gets us a total effect. So by clicking on that button, you can get essentially our indirect and total effects without any problem. Now, just kind of forewarning you that if it's a case that you want some of this additional information, some of these options require you to have a complete data set. So in particular, in my PowerPoint, I demonstrate the residual moments, modification indices, and tests of normality and outliers. And so if you have missing data and essentially you've had to sort of click on this estimate means and intercepts, even if you select residual moments, modification indices, and test for normality and outliers, you're not going to get anything. So just again, forewarning that if you have any missing data, you're not going to be able to obtain those pieces of output, whereas you can still obtain the standardized estimates, squared multiple correlations, and the indirect, direct, and total effects. Now, another option that you might select is Bootstrap right here. So under output, when we selected indirect, direct, and total effects, what we're going to do is what we're basically going to get are the estimates themselves. But if you want to test these for statistical significance, you can't get that through the standard output. So the way to get tests for indirect effects and your total effects, and if you want for direct as well, using bootstrapping, then you can click on under the bootstrapped option right here. And in this case, we'll click on Perform Bootstrap and Bias Corrected Confidence Intervals here. Now the bootstrap by default is set at 200. Generally that's a fairly small number, so I'm going to increase this to 2000. And we've selected Bias Corrected Confidence Intervals. We're just going to stick with the default 90% confidence interval and then select Bootstrapped ML. Now, really importantly is that if you have any missing data, you're not going to be able to use bootstrapping. So it's kind of one of those things that I wish that there was a way around in AMOS, but apparently not. So if it happens to be the case that you have missing data, and you obviously we're going to have to select estimate means and intercepts, then if you try to perform the bootstrap, you're going to basically get an error message that says you can't do that because you've clicked on estimate means and intercepts. And once again, the only way to run your analysis using when you have missing data, the main option is by clicking on that estimate means and intercepts. And so, and by the way, what that does invoke is full information maximum likelihood estimation that is helping to account for the missing data. But nevertheless, just kind of keep that in mind. So our data set does have is complete. There are no missing values on any of our variables, so we can select bootstrap, and under output it makes sense to select residual moments, modification indices, and test for normality and outliers. So now we are ready to go. So what we're going to do is click out of this, and I'll go ahead and click on calculate estimate. So when I click on that button, if you haven't run it before and you haven't saved the model or anything, then it's going to basically make you save your model. So I'm going to go ahead and save I'm going to save over this older model right here. I'm just going to call this demo model and save over it. And that's okay. That's what I wanted to do. And so now the analysis has been run. So you'll see that at the top we have a little toggle that takes you back and forth between your drawing program portion and then the estimates that are included. And you'll notice that we have right now it's set up for unstandardized estimates. If we want standardized estimates, we can just toggle down to standardized estimates. So right now the path coefficients are essentially unstandardized path coefficients, and the double-headed arrows are covariances. Now if we click on standardized estimates, then these are akin to the beta weights in the context of regression analysis, basically standardized path coefficients, and then the double-headed arrows are capturing the correlation between variables. So for instance, the correlation between extroversion and neuroticism is minus 0.37, and the correlation between the two disturbance terms is a little bit hard to read. So in fact, let me just show you another option while I'm there. I'm going to go over here to this little button right here that says move parameter value. So I'm going to click on that button and then go over and highlight my double-headed arrow right here and click on it and then drag, and I can move that parameter estimate around. So this is really handy. So you can see that it says minus 0.32. So that's the correlation between the two disturbance terms. So I'm going to click off of that move parameter estimates option right there. And you'll see in this little box we've got the model chi-square. It says 29.9 degrees of freedom 4. But let's go ahead and open up the output file. So I'm going to click on view text right here, and we get an output file that shows up. And I'll just kind of widen this out a little bit to show you. You'll notice that we have, first off, down here it says model fit. So these are the model fit statistics. And so we use these to evaluate sort of the overall fit of the model. Now, before I go through this, I'm going to go through this really quickly, but I want to highlight that in the PowerPoint, I provide a lot more detail concerning what these measures are and criteria for evaluating them. So be sure to check that out. So just really quickly though, you can see we have the chi-square goodness of fit test value, this CMIN right there. That's the chi-square value, the degrees of freedom for the model, and then the p-value. Traditionally, if this test is statistically significant or indicating statistical significance, that's taken as an indication of poor model fit. It's basically not considered an exact fit. Now, the thing about this particular test is that it is heavily impacted by sample size, and given that SEM models and procedures typically rely on large sample sizes, it's not uncommon for this test result to be significant. So we oftentimes rely on additional measures in order to make our assessment. So you'll notice that we have the goodness of fit index right here and the adjusted goodness of fit index right here. And these values, ideally, they're going to be above 0.90 or 0.95. And so both of these are indicating good model fit. I do want to mention that if you have missing data and you have to click on that estimate means and intercepts button, then both of these indices will not appear in your AMOS output. But right here, both of them are indicating good model fit. We also have the CFI and the TLI right here. So essentially the TLI is the Tucker-Lewis index, CFI is the comparative fit index, and so values that are above 0.90 would be considered acceptable. Above 0.95 would be indication of much closer fit, if you will. So you can see that really both of these are indicating at least acceptable fit to the data, and certainly the CFI is kind of falling into a more ideal range. Now as we scroll down, you'll see that we have the RMSEA, that's the root mean square error of approximation. So for our model, it's 0.076. So values at between 0 and 0.05 would be an indication of close model fit to the data. Values essentially up to about 0.08 would be considered acceptable, and values over 0.10 would be considered an indication of poor model fit. And so you can see that the RMSEA is kind of in that acceptable range, although we wouldn't consider it as an indication of close model fit. You also notice that we have a 90% confidence interval in this P-close test that I also cover that in more detail in the PowerPoint. Now, if we go to the Estimates tab right here and go up to the top, you'll notice that we get our path coefficients as well as the significance test. So you can see that the unstandardized path coefficients are in this estimate column. We have the standard errors, the critical ratio, these are z values, and then we have the p-value for our tests. So you can see that the path from extroversion to positive coping is positive, and you can see it's statistically significant at the conventional 0.05 level. From neuroticism to negative coping, you can see that it's a positive coefficient, and we have statistical significance, which is not a big surprise. If you're higher on neuroticism, you would expect greater problems with negative coping. Then you have neuroticism predicting burnout. You can see we have a negative coefficient, but that path would be considered non-significant. Then we have positive coping to burnout. We have a negative coefficient right here, and we have statistical significance. The negative coping to burnout, positive coefficient and significant. Positive coping to anxiety, we have a negative slope and statistical significance. Between burnout and anxiety, positive and significant relationship. Negative coping and anxiety, positive coefficient, negative and it's statistically significant, excuse me. And then between neuroticism and anxiety, positive and significant path coefficient there. So those are the relationships within our model. If we scroll down, we get the standardized regression weights, which again are essentially akin to those beta weights in the context of multiple regression. If we scroll down a little bit further, we have the covariances in our model. This is the covariance between extroversion and neuroticism, and we have a test of that covariance. That relationship is statistically significant. We have the covariance between our two disturbance terms being negative and significant. If we want the correlations, again, we have those values that are given right here. Now, as we scroll down a little bit further, because we clicked on squared multiple correlations, we have essentially what amounts to the R-square values for each of our endogenous variables. So you can see that the negative coping variable right here is the R-square is 0.011, and we only had one predictor of negative coping in that model, which was neuroticism. So that neuroticism is only accounting for about 1.1% of the variation. For the positive coping, it's 0.005, and we only had extroversion predicting that variable. So essentially, we're accounting for about 0.5% of the variation in that variable. Then with respect to the burnout variable, it's being predicted by positive coping, neuroticism, and negative coping. So the R-square is 0.279, so we're accounting for about 27.9% of the variation. And then anxiety is being predicted by the positive coping, burnout, negative coping, and neuroticism. So those variables combined are accounting for about 34% of the variation. Now you'll see down below we've got these matrices, and you can also access them by double clicking under estimates and going to matrices right here. In this particular case, what we have right here, we have the standardized residual covariance matrix, which can be helpful in terms of identifying potential areas of model misspecification. And I actually go into this in a lot more detail in the PowerPoint, but I'll just kind of highlight a couple of the very large standardized residuals, these right here, basically between extroversion and burnout and extroversion and anxiety. Now, if it's the case that we want to look at the modification indices, we can click on this tab right here, and this gives us a couple of suggestions with respect to parameters that we could theoretically add to the model to improve the fit. Just kind of keep in mind that residual matrix and using modification indices These are very empirically based approaches to trying to perhaps respecify a model, and so I would say use them sparingly and be very attuned to the theoretical implications of those any kind of model respecifications. A lot of times people kind of use these things blindly, and it's very easy to find yourself respecifying a model in a way that doesn't make any theoretical sense. And if you just kind of use all these various recommendations, it would be very easy to overfit your model to the data. And what that basically translates into is a model that doesn't generalize to other population samples. So just keep that in mind. That's kind of a warning with respect to following sort of these empirically based approaches when respecifying a model. But nevertheless, you'll see that what you have right here, these are just a couple of recommendations, if you will, the modification indices for it's got extroversion and D4 and extroversion and D2. And sometimes, by the way, some of the respecifications really don't make a whole lot of sense, so neither of these would make any kind of sense whatsoever. The regression weights basically are path coefficients, is recommending perhaps adding a path from extroversion to burnout and from extroversion to anxiety. But again, you have to kind of weigh this against theory and make sure that if you added in certain parameters that you're doing so sparingly and hopefully consistent with theory. Okay, so looks like we're running a little bit longer than I was hoping to with the video, so I'm just going to briefly highlight. If we click on assessment of normality, you'll see that we get various statistics to assess univariate and multivariate normality, and then we also have this option right here to identify potential multivariate outliers, and all that is again discussed within the PowerPoint, so be sure to check that out. But finally, let's say that I want to look at the indirect effects. I can go back under matrices, and we've got a couple of options. We actually have the indirect effects and standardized indirect effects. I'm going to stick with the indirect effects right here, and so you'll notice that basically these are total indirect effects. So remember what I was saying before about total indirect effects is basically taking all indirect effects between one variable and another variable and adding them together to create a total indirect effect. So you don't have in this output, you don't have anything along the lines of a specific indirect effect. And what I mean by that in that particular case is if I go back down right here and look at our drawing, for instance, the effect of neuroticism on anxiety via burnout only, then if I take this path A right here and multiply by path B right here, that would be a specific indirect effect. If I multiply this path C right here and path D right here, that is a specific indirect effect. If I take this path right here and multiply it by this one right here and then multiply it by this one here, that is yet another specific indirect effect. So if you sum all those together, that is the total indirect effect. And what you have in your output are the total indirect effects. You don't have the specific indirect effects. But if you wanted to get the specific indirect effects, you could do so by using the user-defined estimand option, which is kind of down here at the bottom left, which I'm not going to cover in this video because, again, we're kind of running longer than I was hoping to do. But I will certainly provide resource that will allow you to ultimately find that. I do have a previous video on that, and I'm probably going to be uploading a new one fairly soon. But at any rate, we'll go back to our text and our output file, go back under estimates and our matrices again, and we'll just kind of go back down to our indirect effects. So in here you can see that the indirect effect between neuroticism and burnout is 0.015. That's the total indirect effect of neuroticism on burnout. Then we also have the total indirect effect of neuroticism on anxiety. That's the 0.006. Between extroversion and burnout, the indirect effect is minus 0.006. Extroversion and anxiety minus 0.002. And then we also have these other two indirect effects here. If we want to test those total indirect effects, then what we can do is we can go down, there's a little area down here that's got the bootstrap results. And so in this particular case, if I click on bootstrap confidence, now I get confidence intervals for those indirect effects that have been selected up here, the unstandardized indirect effects. So here you'll see that we've got the lower bound for the confidence interval and the upper bound. So for the indirect effect of neuroticism on anxiety, the lower bound is 0.001, the upper bound is 0.011. So the null hypothesis would be that our total indirect effect is equal to 0. And so if 0 does not fall between the lower and the upper bound for that confidence interval, then we would reject the null hypothesis and infer a non-zero population indirect effect, which is what we would do for this particular interval here. With respect to neuroticism and burnout, the lower bound is is 0.007, the upper bound is 0.022. So again, 0 does not fall between the lower and the upper bound, so we would reject the null and infer a significant indirect effect. If it's the case that that we have a lower bound and upper bound, they have different opposite signs. Basically, the lower bound is minus and the upper bound is a positive sign, then obviously 0 would fall between the lower and the upper bound, and we would end up maintaining the null with respect to that particular indirect effect. Okay, and just really quickly, I want to go back to that issue of specific and total indirect effects. I've already talked about the relationship between neuroticism and anxiety, and we found that the total indirect effect and the confidence interval for the total indirect effect in our output, right here with respect to extroversion, its effect on anxiety right here, you can see that its effect is transmitted through this path right here and this path right here. There's part of the indirect effect, and then we've got extroversion to anxiety also by multiplying this path, and then this path right here. So there's two specific indirect effects that would make up that total indirect effect. So but if it's the case that let's say for instance this path wasn't there at all, then in this particular case right here, if I'm just multiplying this path by this path right here, I would only have the indirect effect. It would be a specific indirect effect, but it would also equal the total indirect effect. So just wanted to kind of give you a little bit more information on those particular topics. But like I said, you can't really get the specific indirect effects in AMOS without using the user-defined estimates option. So the indirect effects are all total indirect effects in the output if you select that. Okay, so that pretty well concludes this video presentation, and I appreciate you watching.